Let's draw the shear force and bending moment diagrams for this beam. So at a fixed support, there's force and moment reactions, but since there's no forces acting on the beam and only a couple, then there must be a moment reaction that counteracts that couple. And now if we take a free body of a section that's at a distance x from the support and expose the internal shear force and bending moment, then from x equals 0 to 1 meter, if we take an equilibrium of forces, then the shear force is 0. And if we take an equilibrium of moments about the rightmost point of this cut section, then we see that the bending moment is constant at 2 kilonewton meters. Now conversely, if we take the cut section at some distance x from the support and expose the internal shear force and bending moment, well, the moment reaction is going to act on this section and the externally applied couple is also going to act on this section. So from x equals 1 meter to 2 meters, taking an equilibrium of forces gives the shear force is equal to 0, and taking an equilibrium of moments about the rightmost point of that section, with anti-clockwise being positive by our convention, then we have minus 2 kilonewton meters plus 2 kilonewton meters plus m is 0. So therefore the bending moment is 0 between x equals 1 and 2 meters. And drawing the shear force diagram, well, that's just going to be 0 kilonewtons across the entire beam. And if we draw the bending moment diagram, from x equals 0 to 1 meter, we have a constant bending moment which has a magnitude of 2 kilonewton meters, and from x equals 1 meter to 2 meters the bending moment is 0. And if you recall our sign convention, sagging moments are positive by this convention. And please subscribe, like and comment to help me reach more students.